Hi guys, as promised we're going to show you the river sampling as well. So we need a bucket, just an aluminium bucket, and this will be where we will pour the filter through. So we'll wash it in the same liquid that our filter will be made of. So basically also always cotton gloves, cotton overalls, so that we don't have polyesters on the sample. So you rinse it. We already done this, so you do this more thoroughly normally. Then you take and with this we're gonna go back to our filter holder and we're gonna sieve it through. Okay, we're at the filter holder. Just as a quick overview, in here you cannot really see it, but on this plastic part with the grooves, there is a filter which has 5 micrometer pore size, and 5 micrometers is really narrow. 5 micrometers basically is 0.005 millimeters, so it's very tiny. Why don't we go even smaller? That's basically because we cannot detect anything smaller. So every microplastic particle that will be below 5 micrometers in diameter, we are not capable of detecting nowadays. So that's why it's 5 micrometers, the limit. Because it's really tightly woven like that, it will not, as you can see now, easily flow through. So this should be 500. So first we pour in 500 milliliters of liquid, and because it's an extremely small mesh size, you need to create a vacuum so that it gets sucked through. So you have a vacuum pump, and pump the science into your sample. Then you see it drip through, and you cannot really, if you look on the filter, you cannot really see a lot of particles get stuck there, but you will eventually notice, if you pump, you will definitely notice that the flow is decreasing ever so steadily. So let's pour in the last 200. See how smooth they flow? And it always depends on how many particles you have in your sample. So if it's a glacial runoff, the filter will already be full after 200 milliliters. If it's a clear spring water, you can pour 4 liters, 5 liters through the filter. No problem. This seemed to have been rather clear water, as you can see, it easily flowed through. And now we will take off the filter. This is always a very delicate move. So first we take off this spring device. Then we take a little piece of wax paper that we have pre-drained a bit in the same solution as the sample. Let me put that over there. So this is basically that all the particles that are on this filter now stay on this filter. So if we're lucky, they stick together. If we're not lucky, it will be a lot of fizzle work. And this is a coffee filter, and this keeps this in a wetter environment, because the filters will be analyzed. It'll take some time. It'll be a few weeks till we can analyze the samples. Nothing's funny.
Yeah. Huh?
By the way, it's 3 o'clock in the morning. But yeah, that's no way.
And it's super cold.
Okay, so it is. It's delicate fizzle work. Okay, you don't want to bend it, twist it. Obviously, kind of. Okay. Just try to not lose it. Sometimes it sticks to your. What's a pinch? Consider it a pinch. in English. 6-year pinch. Close it. Wrap it up in aluminium foil. And you're good.
Pincette is a pinch in English.
Oh!